All right, when we see something like this, like the integral of 1 over a quadratic, we're thinking inverse trig stuff. And now it doesn't look like that, but this is how you approach a problem like this. I'm just going to pull this guy aside. And what I'm going to try to do is I'm going to try to make this look like 1 over x squared plus 1. I'm going to try to make it look like that, where it's not x. Maybe I should have used u. But I want to make it look something like that. So what I'm going to do is I'm going to pull x squared plus 4x and over here plus 5 to the side, and I'm going to complete the square. Now completing the square has you take half the number in front of x, which is 2, square that, which is 4, and then add that over here. Now if I'm on the same line over here, if I do something like that, if I add 4 to this expression, I have to subtract 4 to the same expression to balance things out. But when I do that, that allows me to turn this into x plus 2 squared, and this magically turns into plus 1. So now I can rewrite this integral as 1 over something squared plus 1 dx. And I could do u substitution and make it look like the inverse tangent stuff. So I'm going to let u equal x plus 2, which means du dx is going to equal 1, and du is going to equal dx. So now when I fill all this stuff in, when I put this all together, right, I'll have the integral of 1 over u squared plus 1 du. Okay? That becomes the inverse tangent of u, plus that arbitrary c, of course. And once I plug the fact that u is x plus 2 back into u, I have the inverse tangent of x plus 2 plus c. And that's going to be my guy. Okay, tricky stuff, very tricky stuff.